Today we're going to be walking through Lab 6 and understanding a new topic today called XML. XML stands for Extensible Markup Language. XML is a declarative text-based syntax used in formatting data structures, and it's been used in structuring information in document and logical programming. So you can think of it like HTML, but more flexible for data storage. XML uses the XML data type, which is made up of large object, or LOB, to store the original XML data and a number of member functions to make the data available to SQL. So in the next couple of questions, we're going to understand exactly what this means and see how we can use XML to our advantage in data storage. Let's take a look at question 1. So first off, we see that in question 1, it asks us to create the address book table by using the following attribute information. You have name and the characteristics of the attribute name of varchar2 size 20. Then you have card as an attribute. The characteristics are XML type. And you have creation date as an attribute and the characteristics of that as date. So to get this done, as we know, we begin our usual create table statement. So in this case, we go create table, address book, name, varchar2, size 20. And we have card, and this is the characteristic we have here, sys.xml type. Then we have creation date is date, and then the primary key is name. Right? So let's take a look at what it looks like. So in the address book table, we have name we have the attributes name, card, and creation date as the attributes in the table, right? And so name is obvious, it will store varchar up to 20 characters. Creation date will store date. However, we have this new structure here called card, which is of type XML type, sys XML type. And card can store emails, work phone, cell phone, address, which also has its own attributes of line 1, city, state, zip, comment, etc. Right? So let's take a look at what this means for us in terms of storing data. Okay, so question 2 says the XML card datagram will store contact data for each entry in the address book. It stores the person's email, work phone numbers, cell phone contact, if any, and address. The address consists of one or more lines for the street, the city and state, and zip code. Additionally, for each card, an optional comment is kept. Each address card has a special attribute stating who created the card. We use Oracle Create XML to create XML documents for the following entries and insert these into the address book table. So the first one is an address card was created by Raj for Roger, whose email address is roger12@yahoo.com. Roger has 2 work phone numbers, which are listed here. His cell phone number, and he lives at 123 Main Street, Atlanta, Georgia, with a zip code of 33333. And Roger only works on a night shift. That's the actual comment, right? So let's take a look at the XML insert for this. Alright, so even though this may look a bit confusing and intimidating, it's not. Let's take a look at it in a deep dive. So remember, our structure of the address book table looks like name, card, and creation date. So we have the field Roger, which goes in the name attribute, and then we have the creation date. We have the creation date here, right, which contains system date, which we've spoken about before, right? We'll have the current date of the system, and then card is our XML attribute. Okay, so it says that we use the create XML to create this card. So we have a card created by Raj, and then we're going to have within these two tags, the ACARD tags, we're going to have email, work phone, cell phone, address, which also has multiple attributes of its own, right? I'm going to be able to store these details in this one card attribute. So remember, when we created the table, we only had 3 attributes. Let's take a look. We would only use these three attributes here: name, card, and creation date. This is how these are employed. Okay, right? So we see we have name, we have the system date, and within the card option, we have all these comments here which make up our XML. Yes, and we use the create XML to create our card. Okay, so let's take a look at the elements inside. So we notice that we have to do similar inserts for Bobby and Tommy, Abe, Tony, and Frank, right? And if we look at Bobby's structure, right, we'll notice that we have no self or comment. Okay, this also shows how versatile XML is in storing of data. Yes. And then we also have for Tommy, we have no address or comment. We just have his cell phone information. And for Ram, it includes kids in his comment, and Tony works for CNN in his comment, right? And for Frank, he has a dog, the name of his dog in his comment as well. So again, this shows the versatility of using XML in storing of data. So how would this have been done without this, or without using XML? We would have likely created multiple fields for email or work phone, address, comments, etc. And in some areas where there would not have been data entry, for example, in the comment section here. So Frank and Tony both have comments, right? But we notice that Tommy doesn't have a comment. So in that case, what would we have done? We would have simply had those fields available in our table, but not used those attributes at all. We wouldn't have added anything in those attributes, and it would have been null. In this case, we're using the space allotted to the card, but we're just not including them in the card itself. We're just making the card custom or as it needs to be. It's time to consider question 3. Extract the XML datagram for Roger as a club or character large object value. Let's take a look at the code. You say select a.card.getClubVal as address from address book A, where a.name equals Roger. So okay, a couple things to unpack here. We first have a label for this function. So we're going to call the a.card.getClubVal the address, right? And then from address book we're going to have an alias of A, which is why A is referenced here as well as here, right? So we don't have to write address book over and over again, where a.name equals Roger. Now let's take a look at what happens in our table. we're able to see Roger's full details, Roger's full details in this address card, right? So you notice that the label here says address, right? And so we see the card created by Raj, and this is Roger's email, his phone's cell phone, his address, everything, and the comment: he works in the night shift. Four, get the names and email addresses of all individuals. The solution will show you two different ways to do this, and both will give you the exact same result. A list of names and the emails. So let's explain the differences very quickly. The first way uses a member function syntax, which is like calling a method on the XML type object, right? So select a.name, a.card, .extract, a.card/email, .getStringVal as email from address book A. So here, the card is using the acard.extract is a method on the card column, and it pulls the XML fragment with XPath. So it pulls this, yeah, and then the getStringVal here converts it to plain text so we can understand it. And the second method would be just a standalone SQL function. So again, we would have select a.name, extract a.card, a card/email. Get string val is again the function that will convert it to plain text, and it's coming again from address book A. Yes, this is the exact same function, but the extract function here is called as a regular function with the column and XPath as the arguments. So the performance is identical. Oracle handles it both the same way. The member style, the first style, feels more object oriented, while the standalone is more classic SQL. So you can choose whichever one is easier for you. But extract grabs the XML piece, and the getStringVal converts it to a string. That's all. Those are the only differences there. So let's take a look at them in practice. This is the initial. This is the member function syntax. See here, member function on the card itself, a card, right? So this is the output we have for that. So your name and emails, and this is the second way, which is using standalone. Run that. You get the same output, name and emails. Okay, and getStringVal just converts them to plain text so that we can understand what we're reading. 5. Extract the names and states of all individuals. This question builds on question 4 by going deeper into the XML structure. So we're pulling the name from the table and the state, like Georgia, from the inside state tag in the card's address. So remember, not everyone has an address, okay? So Tommy won't show up here since he has no addressed element. The solution shows two equivalent ways to look at this. Both of them use XPath to navigate. So we see here the acard address state and the text function. Acard address state. The text function here, it just grabs the inner text like GA with like Georgia, right? So that's the state we're looking for with all the tags. So the first way, it uses a member function syntax. So remember, we used that in the previous question. So we say select a.name, a.card.extract, a card address state text, getStringVal as a state from address book A. So here, the acard extract method, which is this, it is on the XML type column itself, okay? And that drills down to the text on the inside, to the state tag, and the getString value, which is this, it converts it to plain text. The second way would be using the extract value shortcut. So we would say this is the extract value here. Right? That's the shortcut there. Using the extract value shortcut. So we say select a.name extract value a.card slash a card address state as state from address book. So again, they're going to give you the same results. Okay, so the extract value here is a direct SQL function that pulls just a text value. So there's no need for a text function as we had in the previous question, in the previous solution. Okay, or the getString value, as a matter of fact, if you notice, it also is not there. Okay, it's just simpler for basic text extraction, and both give the same results, and performance is identical. So if you use the extract value for quick pulls like this, you can stick to the extract if you really need more flexibility later. So you're using, just for simplicity, you can use the extract value. And for more flexibility, later you can use the member function. Let's take a look at how it looks in Oracle. Remember, it's going to give you the exact same result. Okay, so we see name and state, and in this case we're using the member function, right, plus getString val to convert the XML to text, and in using the extra value, we get the same result, except it's just a shorter, quicker way to get it done. But the performance is pretty much the same. Okay. Right. So running either one of them, you'll see Roger, Bobby, Tony, Tommy, Abe, Frank. But Tommy has no state address because he doesn't have a state listed on his card. Extract the names of all individuals who live in Atlanta. That is to say, where the city equals Atlanta. Let's take a look at the code. We can see where it says select a.name from address book A, where a.card.exist node, a card address and city equals Atlanta equals 1. So the exist node here is key. Okay, the exist node function is key. It checks if the specified node in the XML using the XPath with the condition with the XPath here with the condition in brackets. If it's Atlanta, it returns 1 if it's true and 0 if it's false. So basically we're going to filter it with 1 because we want to know if it's equal to Atlanta, right? And the second version of that would be the standalone feature, where again we have the exist node, again we have the XPath, and again we have the condition, again equal to 1, but this is a more direct route. So this is the standalone version of it. So it's the same thing, just the procedural styles are different. It's procedural style versus object oriented, and the result you will get would be the same on both ends. It will both be Roger, Bobby, and Frank. This is with the style with the method, the member method, and this is the standalone. Again, same characters. Find the name and the second work phone number of all persons who have a second work phone. Let's take a look at the code. Select a.name, a.card.extract, a.card slash wphone2, which is the position we're looking for, slash text, which is the text function, dot getString val as work phone from address book A, where a.card exists node, a card work phone 2 equals 1. So the XPath 2, so we would have seen here and here, right? It selects the second work phone element. So Roger has 2, so he'll show up with 1115678. So that would be his phone number. And we use the exist node again, right? in the way to filter only those with the second phone. So we see in the XPath, we see work phone, we see position 2, and we want to make sure that they do have one. So we're just confirming 1. So 1 yes, 1 if it's positive, 0 if they don't have one. Yeah. And the standalone version is the same thing more or less, just as the examples we did previously. Example, using a standalone version here, using the X node, the exists node again, with the work phone location of 2 equals 1. Let's take a look at it in SQL. So we have again Roger coming up with his second work phone here, right? And we're going to get the same value when we use the standalone method. So we see here the first method we use is the member method, and the second method here would be standalone method. Okay, same value. Okay. All right. So only Roger would match here because he's the only one who has a second work phone. Question 8. Find the name and the address of the person with the email address roger12@yahoo.com. Let's take a look at the code. Select a.name, acard.extract, acard/address, .getStringVal as Roger address from address book A, where a.card.existNode, acard/email equals roger12@yahoo.com equals 1, or select a.name, extract a.card address getStringVal as Roger address from address book A, where exists node a.card equals a.card email equals roger12@yahoo.com again equals 1. So the first thing we notice is that we want to ensure that both of these we want to ensure that the email address does exist. That's what we're filtering it by. Yes. And so in order to see that, let's take a look at it this way. Let's take a look here. Okay, so we're going to get Roger's address, right? That's what we're asking for. Yeah, his address. Yes. And we're going to basically be looking for where his email address is equal to roger12@yahoo.com, right? That's what we're filtering this result by. Let's take a look at it with the standalone. We're going to get the same result. Okay. Same result as we've noticed from every other example we've done in the last couple of minutes. Yes, Roger and his entire address. Again, it was filtered by his email address. Question 9. Find the names and email addresses of persons whose entries were created by RAM. So remember that was also part of the dataset that we have a created by field. We're also going to be using that now to determine which entries were created by RAM. Let's take a look at the code. We see select a.name, a.card extract, acard email text, and getStringVal from address book A, where a.card.extract acard / created by .getStringVal equals RAM. And we have the more direct method as well. Select a.name, a.card extract acard email text function .getStringVal equals from address book A, we extract a.card. Again, we have the X code, the X path here, created by get string val equals ram. And now we're going to take a look at it here. We see here by running the initial one, we're going to get all of these cards that were created by ram. Right, we have the names and the email addresses of those. In the second version of it, which is the standalone version, right? Let's clean this up a bit. Okay, so we get the same values here again, but this is just a more direct version using a standalone version of the same query. Okay, so the standalone version uses the extract, as we see here. Okay, for both parts, and so there's no need for the exist node. Let's take a look. Right, so they both use the extract here. Right, so we're not using the exist node in each of these in either of these queries. Change the email address of Roger in the address book to roger12@earthlink.com. Let's see how we do that. Okay, so you say update address book set card equals sys.xml type create XML, and then we basically create over the entire card, right? That's one way. So you're using the create XML option to make that adjustment in the system, right? However, this is inefficient because we're going to have to recopy the entire XML as we see here, right? So we don't really want to use this. So a better way is to update address book and set card equals update XML. So we were using create XML, and now we're using update XML. Right, update XML the card, and you have the XPath and the text, and this is what you want to now change it to. So we say roger12@earthlink.com, and then the creation date will also be system date, so it'll be updated as well, where name equals Roger. So update XML lets you target just one part. So in this case, we're using the email text, using the XPath, and we replace it without touching the rest of the code or the rest of the XML. This is more precise and safer. This is more precise and safer for larger XML systems. Let's take a look at it. Okay. Right, so now we have one row updated here, where Roger is now going to be roger12@earthlink.com. Have to consider deletion. So we have to now, in question 11, it says delete from the address book table all the addresses whose zip code is 33333. Let's see how we do it. Encode. Okay, so we say again update address book A, where we set a.card equals delete XML, and we say a card, we use the delete XML function, we say a.card, and we have the XPath, a card address, where a.card.extract equal function, using the extract function, and the XPath here, a card slash address slash zip text dot get number val equals 33333, and this will help us now to delete those values. Okay, let's take a look at it. Right, run it. Okay, great. Now we have 2 rows here updated. Okay. And so delete XML removes the entire address node. The entire address node is removed based on the XPath. So if you notice, it said update, right? Updates address book. So in this case, what we're doing is that we're just removing the address node, which is inside the XML, based on the XPath, which we've given here, right? And then we filter it with what we want the zip to say. So we filter it with the extract on the zip text by using the get number val right here, which will take into consideration what we put in here, and then we treat it as a number for comparison. And so this only affects Roger, Bobby, and Frank, and that's how you delete the contents of the XML in your database. Okay, so please review these questions and try to understand the uses of the XML, how it's formatted, how we structure it, and how we're going to be using it in the exam. Take an example of how the questions were structured as well as how the answers were formatted. And good luck in your upcoming exams.